Right, we're going to move on to a set which I know I've got a Maxcom 30 with a corker of a fault on it. I just need to do some of this first. So, this belongs to our mystery benefactor Alan. He sent 2 sets in this in the York JCB861. I thought we'd do this first, because yesterday's set was a Cybernet 134 and I don't really want to have all the same kind of innards, even when they're different sets. So I like these very much. We did that road trip and we used the Maxcom version of this. The only difficulty when you actually use these is, are you sure that this knob is actually on the channel you want? So, not easy to use. So this one, good grief, serial number 15. Wow. Right, so it's the later version. You don't get high-low power on this model, and that's come without its blow-molded box, or its aerial, or any of its adapters, so we just run through it as it is. I've got another 3 of these, which we're going to be showing over the course. I bought that batch of 3 with batteries glued to them, and that's why I've got quite a few. I need to go through them. So we need our SO239 to Motorola adapter. So it's going to be a bit lossy. Just connect that up to the power supply. I'm happy to run these at 13.8 volts. Not all of the sets. I've also got one of our own, which is the Cybernet ZX. One is it? What I would like to do with this is, when we get to the on-the-air test, subject to being able to fix it, I think we're going to do what we did with the Maxcom the other day, and we're going to get Mr. Chippy to go out and do the normal on-the-air test where we've got it plugged into the roof aerial, and then I'll have him come back, take this radio out with him, and use it with the telescopic mag mount provided in the kit. Now, this, as I say, is mystery benefactor Alan's, and it's come body only. So the thing is, we will then take the aerial out of one of our kits to make it up for the test. So I think that's the right thing to do, because I want to kind of retest all these emergency sets with that double test like we did before, straight from the on-the-air test to the field test. That's the plan. So we'll switch this on. We will switch this on. It is on. Why are we getting nothing? Right. Picture in picture on. Wrong meter. No, it's the right meter. So on the low scale, let's go to transmit, and it is doing 2.15 watts. I'll tell you what, we'll put it on channel 20 to be fair. Doing 2.1 watt. I don't get where it is with the frequency. The knob's in the wrong place. I'll just go to the frequency counter because the knob must be in the wrong place. So I've got that on channel 19 and it's showing 2779, which I presume would be 125 if it was on frequency. I'll tell you what, we'll just jot down that the frequency is that far out. 2779000. not illegally out, but it's going to be noticeably out. So I've got to take the knobs off anyway, but the knob's in the wrong position. So it's 2.2. It's 2.2 watts, and the radio's drawing 660 milliamps. Let's go to channel 40. Probably one more than that. Let's have a look. Yeah. It's doing 2.4 watts. Channel 1, 2.2 watts. I'll just have a quick look at the deviation if we get back to channel 20. Did we say that was 20? Did we say that was channel 20? That one. Wallow. It says 1.5 on there. We'll not write that down, just in case the thing's playing up. So, with all that in mind, let's go to set the signal generator so that it's as off frequency as the radio. So we'll take that from being 79125 to 79 all the O's. Let's hope the reference crystal isn't knackered. Right. Oh, we can't do the cyanide without taking it apart. But let's listen. That's 1 microvolt. That's 0.3. So we can't hear 0.3. And it stops working properly about 0.65 microvolts. So we'll take all the knobs off, get it opened up. At least we'll be able to put the knob back on in the right place. I think the realistic TRC 1004 was the Rolls Royce of these. We've definitely got more than one of those somewhere. Mind you, it's $149.99. I'm not surprised there was a Rolls Royce of them. So it's exactly the same board in this as the Maxcom 70, and of course it's made by Maxon. Never said we'd get those screws out. But this one's in non-faded condition, which is nice. It's actually, there's still the smell of new radio coming off it after 40 years. So now we can clip onto the meter. We can clip the meter onto the speaker and get a cyanide reading. Switch it back on. Should only need it positive. Yeah. Just put enough volume on for a sensible amount, and we'll put the cyanide meter on the inset picture. There we go for 12 dB. We've got 0.98 microvolts. I think it's about where the manufacturer says it should be. For 10 dB. 0.93, and for 20 it is 2.1. Squelch is 0.94. 6.8 millivolts. It's far too high. And let's put the threshold in. It's 0.98, which is fair enough. So, it doesn't have a meter. Well, that's ticked a whole pile of boxes there. Right. So let's do it to it. We're not going to be doing the VCM. Transmit. Going down this row here. They're the opposite way on to the... You've got the sockets at the bottom of the max conversion. So we want to show the main meter, and on the 3-watt scale. There is not a low power switch on these, which is a shame. So that wasn't at central. I'll tell you what, let's put it on frequency first. It's not going to do it, is it? Right. Well, our mystery benefactor, Alan, sent us a scrap Maxcom 7E. So our mystery benefactor, Alan, can have his reference crystal out of his scrap one. I'll go across to our storage shed and see if I can find that. Right, so I've unshouldered, I've unshouldered the shield plate from this. And the reference crystal is just down there. So if we unsolder the reference crystal, this one's been played with till it was killed. I'll show you in a moment. So it's had wires shoved into it, and then it's been overvolted and it's blown up that capacitor. I don't know whether there's other damage and I'm not interested, but it's a good source for parts, especially when the person who donated this needs a part on it. Didn't say I could get to it though, did I? Let's hope it works. And that speaker's probably bigger than what you get in modern CB radios. Right, 10.24. Let's pop the power off. Now we'll have to get this out of its innards. To disconnect the loading coil. Hopefully it all just comes away. It does. And the shield plate is the other way on. you know, I did a 3-year college course on Mechacon controls within video recorders. Why? What a waste of time and money. I never thought there'd be a time when there wouldn't be video recorders that had tape in it. I've got a stack of untested video recorders. I think we've got 28 of them. And I put them on eBay with no minimum bid. And I think I got £1.07 for all 28. And they were on our account books with like 7,000 quid value. Oh dear, oh dear. Don't think I paid any tax that year. Oh, come on. This crystal's still got its glue on it. So, unlike the one in the donor set, there we are. I'm soldering the wrong point, no wonder it won't come out. So that's the Duff one. Let's see if we can manage to thread this. Oh, a lovely picture of the Maxon factory from the 80s. And there must be about 200 women sat at benches on a production line, each soldering in their number of parts they have to solder in. The idea of leaving the wires long is so the crystal doesn't get shock. So if you've got them right down to the board, there's a possibility if the set's dropped, the crystal will crack with the shock. So the idea of leaving it dangling gives it some more shock resistance. I'll just solder up the bit I shouldn't have unsoldered. And I'll tell you what, we'll put the shield plate back as if I fixed it. Thing is, it can affect the frequency. It actually fits, which is more than another thing I could say for a lot of modern sets. You take shield plates off latest sets and they don't always go back nicely. So while I'm faffing around doing this, of course, the thing's cooling down. I will have to come back to it because it's bound to, the heat from soldering is bound to affect it. I think we've got to move that upwards like that. There we are, done it. I'll even solder that on so I can curse more when I've got to take it all apart again. So it's all already gone now from a retune and test to a repair. There we go. Power it up. And let's see, when we're going to transmit, what we've got. Well, it's now too high, so that's fantastic. Going higher. Well, crystalline is donor set. Just the job. So you see how that works out? He gets it back gratis. That can go in our vertical filing cabinet. So it's now on frequency. So let's get back onto the transmitter. I'll recheck that in about an hour's time. So we did the first coil. I'll go back on the first coil just in case. Moving to the driver. We're now at 2.8 watts. That takes us to 3. We'll change scales now. See whether we can get a bit more out of it with the final coil. The answer is not necessarily. So it's 3 watts this one. Go back to the 3 watt scale. It's just gone just a bit past. So again, we'll come back to that when it's cooled down before writing down any figures. So whilst it's cooling down, we'll just do the deviation. So using the test set behind me, because I can't trust this one on its deviation meter. Oh. This is the fun bit. Low. Yeah, it's a bit low. Low. That's now 2.5 as a peak, and averaging around 2.2. So see what the Marconi test set has to say for itself now, because it was probably right when it was 1.6. Right, let's look at it now. Wow, it's spot on. It's spot on. So it's not lying today. So it was 1.6. It's now 2.2 to 2.5 kilohertz. Let's see if we can get something more out of the receiver. So we've gone from 2.2 to 3 watts. Just so we're going to just check that when the set's cooled down. Reset the signal generator for 79125 now the radio's on frequency. Put 100 microvolts on it. I'll just show you the frequency counter now. That's the signal generator showing. Now we'll go to the oscilloscope. Let's put sufficient volume on to get a decent trace, and we'll do the detector. And I can't remember whether it's that one or that one, but it doesn't matter. It is that one, and it was spot on. So we'll go to the cyanide meter. I've put a signal such that I've got about 4 dBs on the meter, so we're not saturating it. We'll go through the front end. We've gained a little tiny bit there. We've gained a little tiny bit more. Let's go through that again. So that's 2 little tiny bits. I'll just drop the attenuator again. And that was well out. Right, we'll get a new cyanide reading. It's got no difference. It's 0.98. For 10 dB, 0.935, 0.93. And for 20, it's now 2. It's actually 2.2. So it's actually, now it's tuned properly, it's actually marginally worse. Of course, it isn't really. This is where if you did it before and after with scratchy corner, that's when you would notice the difference. This is all down to noise. Right, let's get this squelch adjusted. Disconnect that from the test gear. And the other preset, there is another. It's down there. Right, squelch, here we come. That's now 100 microvolts maximum, and I'm not showing you the attenuator. Let's do that again. So 0.3, 1, 3, 10, 30, 100. So drop that back to 0.3, put the signal generator to standby, set the squelch threshold, and let's see when it comes in now. The answer is 0.82. Got a nice improvement there. Right, let's look back at transmit. So I'm going to put the knob on as a temporary measure with the pointer upwards. So I'm expecting 1 and 40 to be down here at the bottom. So we'll go back to the main meter, key it up. The 3 watts is full scale deflection to there, and it's beyond it. So I can safely say I'm going to put 3.1. Let's go to channel 40. We'll go back to the 3 watt scale. I'm going to put the knob on the wrong shaft. So it's going to be about there. Key it up. 2799125 is channel 40. And channel 1 3.2 watts, 3.0 watts. Back to channel 20. And the frequency is 2779130. Just twaggle it down a little tiny bit from that. 125, I mean that's spot on. And I think things are still cooling down a little bit, so 2779125. And the transmit current is now 682 milliamps for that 0.8 watt of a gain. This hardly affects the range, as we've said a million times. Once you get between, after 2.5 watts, there's not that much of a difference between quite a big increase. So it's reference crystal and it's free of charge because a viewer donated it, the very viewer whose job this is. I'm going to cut the power because when you start putting the screws in, it goes without saying, you end up pressing the transmit button. So although we've improved the receiver, it hasn't shown on the synod meter. We're doing on the air test later for that. So we can put this knob safely back at channel 20. I'm just going to go I'm going to go to channel 1 and make sure that that lines up with channel 1. Oh, that's not gone in right. Right, try again. So, as I was saying, we'll put it to channel 1. Just make sure that that is channel 1. It is 60124 it's showing. So that'll be channel 40. 99127 it's showing. and that'll be channel 20 79125. So at least the knob's in the right place. Channel knob in wrong position. Out one channel, but it was so off frequency that it, you know, how could you tell? Continue to line these, so we have another 3 to look at in due course, but I think we'll be doing that batch of stuff I bought between the customer repairs. Right, we will plug it into the aerial. An Antron 99. Somebody asked what these are called. It is a PL259 plug, and the socket it goes into is called an SO239, and it's standard on Citizens Band radio. They were also called UHF connectors because this is a 1930s design, and in those days UHF was anything above 30 megs. So what we will call now VHF used to be called UHF in a bygone age. If you go much above 125 megs, they become lossy. So when you see 2 meter equipment for ham radio with these on, you're starting to be getting lossy. And if you see UHF equipment, well, you need to be changing it for an N type, which was a Bell Laboratories thing in the 1940s, came later. You got the BNC, I think that was Bell Laboratories 2. That was late 1930s, if I remember, the BNC. That's less lossy, and the N type, like we have on the test equipment here, was a 1940s design, as I say, from Bell. I think it was Mr. Neil was the person behind it, and that was why it got called the N type, after N for Neil. Not his first name, unless his first name was Neil as well, but it wasn't. So that's what that is, and they're all the later things. We've seen those pretty dreary SMA connectors, haven't we, on cheap Chinese walkie-talkies, which were aimed at the cable industry in the 1960s. But to put an RCA connector on the back of this is really, really lossy, and that's what they did. So that's, in a shorter form, it's phono, RCA phono, and in its longer form, it's Motorola, and that was for the back of car radios. So a bit chat there about connectors. Let's see if we can hear anybody. One Anna Roger. I don't think they're out of bed yet. That's Channel 8. So we were head in a bucket. $19 a Roger. No. We'll pop the squelch up and we'll do an on-the-air test later. I say we're going to follow that then with a field test using our magnetic aerial from another kit, so we can get this. It's probably going to be similar range. If you remember the Maxcom 7E, we got 4 miles receive and 6 miles transmit on the magnetic aerial which comes with these. So thanks for watching. Glad to be able to sort one out for our Mr. Benefactor. First time he sent something in. And the Midland, there isn't. There's a York 861 from him tomorrow, and that's Thursday. And then hopefully Friday, I'm going to pop these over to the intermediary in the town that I've been given as a postal address. I thought I'd pop them in person just so we know that they get there safely. So that's what we'll be doing. I'm not going to do road trips there because we're just going to go and meet. I'll probably put them on somebody's doorstep. That'll be it. Thanks for watching.